I'm Joy, and I'm coming to you from the Flight Research Building, also called the hangar at NASA Glenn Research Center in Cleveland, Ohio. NASA has a great challenge to share with you, and we want to see your solution. It's called Let It Glide. For 100 years, even before NASA existed, we have been studying flight in this country. In 1915, the National Advisory Committee for Aeronautics, or the NACA, was founded with the goal to improve flight. In fact, this hangar was built in 1942 for the NACA to house aircraft that allowed aeronautic and scientific research to be conducted from the air. In 1958, the NACA became NASA as we know it today. Even after 100 years of research, NASA continues to study and improve flight, and we can use your help. Today, I'm here with Glenn Research Center's Deputy Chief of Aircraft Operations, Kurt Blankenship. Kurt, can you tell us a little bit about the research being done using these aircraft?
Of course, Joy. We load scientific equipment into these planes and study the world around us, from as low as a few hundred feet above the ground up to 50,000 feet in the air. We are currently using our Twin Otter aircraft to study the harmful algae blooms in Lake Erie, and our Learjet is being used to test the accuracy of solar cells in the stratosphere. We are also researching unmanned aircraft systems like drones and how they will integrate with piloted aircraft.
What determines which planes you use for which research?
That's a great question. Aircraft are designed differently for different capabilities. For example, the Twin Otter was designed to fly at lower altitudes and land on short fields, while the Learjet was made to fly high and fast. Our S-3 Viking does great down low as well as in the mid-altitudes. You'll notice wing shapes and thicknesses, fuselage designs, and engines are different depending on the aircraft's intended mission or use. Based on these features, the planes will perform differently, giving us the ability to fly greater distances at higher altitudes and faster speeds, or carry more weight. We then choose the plane that will do the best job for the science we are conducting on board.
So here's where you come in. To better understand these flight concepts, on a smaller scale, we want you to design and build a glider out of a shoebox that could model flying one of these scientific payloads, taking into consideration the features Kurt mentioned before. Your glider should be built around the shoebox, keeping the box itself intact. To complete the challenge, you and your team will explore the 4 forces of flight and work through the engineering design process to come up with the best design possible. There will be opportunities to interact with NASA's subject matter experts like Kurt throughout the challenge.
When you've created your final solution, your team will present it to us.
As future scientists and engineers, NASA needs your help in solving this real-world problem. Good luck, and we look forward to seeing your solutions.